Alrighty, last but not least, numbers 14 through 19. There's some sums now, so we're going to have to think through our sum formulas. So for this first section, what I want to do first is actually go through and figure out what type of sequence it is, as long as it's arithmetic or geometric. Remember again, arithmetic we're looking for something linear, and geometric we're looking for that exponential. So 14, it's not in order, but hopefully you can recognize this is an arithmetic sequence, right? It's linear. You've got a slope right here of -3. 15, you've got an exponent and it's a variable, so that is geometric. And because we have an ending value on that top of the sigma, it's a finite geometric. 16, geometric, it looks exponential, and you've got an infinite up top, so infinite geometric. Same thing with 17, you've got something to a power that's a variable, and there's an infinity, so that would be our infinite geometric. Okay, so for arithmetic, we're doing n over 2 times a1 plus an. So we need to know how many terms there are. So top minus bottom plus 1 tells me there are 8 terms. So we're going to do the sum of 8 terms, 8 over 2. First term we get by plugging in the bottom number. So 10 minus 3 would be 7. And 8th term we'd get by plugging in the top number. 10 minus 24 is -14. So that would be 4 times -7, which equals -28 for your sum. 15, your finite geometric. Again, we need to know 3 things. How many terms there are. We need to know A1. We need to know R. So A1, 1 minus R to the n over 1 minus R. So A1, first term, we get by plugging in 0 in this case. So when we plug in 0, that 0 power makes that term 1. So first term is 400. R is always the number that's being raised to the power, so R is 1.08. Now for n, again, top minus bottom plus 1 tells us there are 6 terms. So we're actually finding the sum of 6 terms here. To the 6th over 1 minus 1.08. So I'm going to pull up my calculator. We're doing 400 times the quantity, 1 minus 1.08 to the 6th, divided by 1 minus 1.08. And we have a sum of 2,934.37. Okay, so the next two are both infinite geometric. So we have our formula, S equals A1 over 1 minus R. But remember, you can only use this if the absolute value of R is smaller than 1. So your numbers are getting smaller as they progress through the sequence. Remember, the number that's being raised to the power is your R. So R is 0.1. That's definitely smaller than 1. So we can go ahead and find our sum. So we just need first term. I'm going to plug in 1. So 0.1 to the 0 is still 1. So 1.3 should be our first term. 1 minus 0.1 is our R, or is our denominator. So let's get this here. Oops. Oh, hold on. Let's get them up. So 1.3 divided by quantity, 1 minus 0.1, gives us a sum of 1.4 repeating. Okay. And then in number 17, again, infinite geometric, but look here, your R value is 3/2. That's definitely greater than 1, so there's no way we can add all those numbers together. Okay, 18, just to set up the problem, we're finding the sum of the first 100 positive multiples of 5. Think through your multiples of 5. 5, 10, 15, 20, etc. What kind of pattern are you looking at? Looks like each time we are adding 5. So this is an arithmetic sequence. Your difference is 5. We need to know 3 things. How many terms? There would obviously be 100 terms. So 100 over 2. We need to know first term. There it is, 5. We also need to know the 100th term. Well, if these are all multiples of 5, your 100th term should just be 5 times 100. So 500. So for our sum, we're doing 50 times 505, which is, move this guy over, 50 times 505. Our answer is 25,250. Okay, last one, again, is arithmetic. Your starting salary A1 is 34,000. You're increasing 2250. We are finding the 5th year. So it's not a total, it's just a specific term. And since the bell rang, I'm going to leave you there.